Okay, we have split out our 2,000 to 2,500 gram sample mix for the GMM test. This is often called the rice test. We take that sample then and put it in a large flat pan like this. Part of this test, what we have to do is cool the sample off and break it up. While the sample is cooling, it goes a little faster in fact if you put it in front of a fan. You're able to just stand there and stir it while it's cooling off. It'll generally break up very easily. If for some reason you get called away, come back, it may have started to set up a little bit, in which case you can just take the glove, pick it up, rub it, break it up. In front of a fan like this, it'll cool off to room temperature in just a few minutes. During this process, you need to watch for any uncoated aggregate. If you do see any uncoated particles or fractured particles where there's an exposed aggregate surface, just take those particles out, remove them. That's why you always want to weigh this up a little bit over 2,000 grams as a minimum, in case you have to remove some material or you lose some material during the process. We always tell people to weigh it up at least 2,050 grams or so, just to be sure that when you run the test, you have over 2,000 grams. The whole purpose of this is to get fine material that's all agglomerate, in other words the sand particles that are all stuck together with asphalt, and get them broken up to less than 1/4 of an inch in size. And that's to facilitate the removal of the air, because the purpose of this test is to get the volume of the mix with no air voids whatsoever. The way we do that is we're going to stick it inside a picnometer, which is just a vessel of a known volume, cover it with water and put it under vacuum, and we're going to suck all the air out. So if this was all just one big chunk, it would be difficult to get all the air out all the way to the center of the material. If we break up all of those agglomerates and fines down to 1/4 of an inch, then we have made it easy for the air to escape from within all of the material. We're not trying to get any water into the aggregate. That's why we remove the fractured particles or uncoated particles. That would change the results, because all we want is the volume of the coated aggregate. Okay, this is nearly ready to go. It's almost to room temperature, so I can start preparing the equipment. This is the type of Piconometer that the Iowa DOT uses. It's just a 3,000 milliliter flask. Heavy walls can take the vacuum. We like to use this for demonstration purposes because you can actually see what's going on. It has a cover plate that goes with it. That's how we get the known volume. When this is calibrated, it's simply filled with water at various temperatures, and we produce a calibration chart for it. The cover plate, notice, has a number on it. The Picnometer has a number on it. They are matched. They are not interchangeable with other picnometers. This device here is called a vibrating table. We're going to mount the mix in the pick on that to help facilitate the removal of air. So the first thing I've got to do is get the weight of my sample and make sure that it's in the Picnometer. Since this is glass, one of the things we need to do is put some water in here first before I transfer the material into the pick. So I have a water bath here with some water in it. At the end of this test, we have to be between 72 and 82 degrees. So I generally start with water in the vicinity of 80 degrees because we're going to lose some temperature during the process of the test. So I'm going to put about 2,000 milliliters of water in here just to cushion when I drop the sample in there I don't break the glass. We've got about 2,000 milliliters of water in the Picnometer. Now I can take that pick And now I need to get the weight of the sample in the picnometer. There's various ways to do that. I could weigh the pan with the sample in it, put the sample in the pick, weigh the empty pan, do the subtraction. We don't like to use that method because if any material were to get lost, you would get an incorrect weight in the pick. To make sure that we get exactly what's in the pick, what we like to do is simply put the pick with the little bit of water in it on the scale and zero the scale. Alright, so now I need to transfer the sample into the picnometer. We have a funnel to facilitate that. The sample is all broken up, ready to go. Down to room temperature. Sample all go in there. Alright, since I turned the scale with the water in there, now I can set the sample back and get the actual amount of material that was placed into the pick, which is your sample weight. That is W in the formula, 2071.4. Now at this point we have to make sure the sample is completely submerged. So we'll give it a little shake if it's not. It'll usually settle a little bit. And we're going to mount it on this vibrating table. And it just has to be snug in here, it doesn't have to be real tight. There we go. Place the cork in here. And I turn on my vacuum pump. We're using a aspirator as a vacuum pump here. We may use actual vacuum pumps or oiled vacuum pumps. Anything that can produce the proper vacuum is okay. We like the aspirator because it uses water to create the vacuum, so there's no danger of pulling any water into the device. This device is called a manometer. It measures vacuum in millimeters of absolute pressure. There's a needle valve on here for releasing the vacuum. That has to be completely closed in order to get the vacuum down to the required amount. The required vacuum is 25 to 30 millimeters of absolute pressure, which is quite a bit. The atmospheric pressure is around 720 millimeters of absolute pressure. Some vacuum pumps will pull it down a little faster than this. The aspirators are a little slower than some of the vacuum pumps. It will get there. And that has to be maintained between 25 and 30 millimeters of absolute pressure for 15 minutes. Once it hits 30, I start the vibrating table and start a 15-minute timer. If it drops below 25, we have to just mess with that needle valve a little bit. So it stabilizes. 25 and 30. Automatic equipment that controls vacuum. It's called the auto rice. The Iowa DOT has purchased that for the district labs. Many contractors have that now. It actually controls the vacuum for you. You don't have to mess around like I just did there with the needle valve. Whatever you've got, whether you're doing it manually or automatically, what it's going to do is maintain this vacuum now under vibration between 25 and 30 millimeters for that 15-minute time period. You can use a timer like I have. It'll beep at 15 minutes, or you can use a stopwatch, because you have to watch it. You'll notice the material is moving around a little bit. That's what the intent of the vibrating table is that it moves around, helps to facilitate getting all the trapped air bubbles out of there. At the end of the 15 minutes, we stop the timer, stop the vibrator, turn off the vacuum pump, and then we use the needle valve to release the vacuum slowly. Doesn't have to be real slow. 20 seconds or so is about right. You just don't want to pop the cork out of there when it's under full vacuum, or you'll probably break the manometer. As soon as it's back over 700, then we can remove the cork and go to the next stage of the test. Now I need to fill the picnometer to the top with water at the same temperature, so we'll go back to the water bath we have here. Fill the pick. Now I just spent 15 minutes sucking all the air out of here, and I've got to pour water into the pick. So how do I do that? Very carefully at first. We'll run some down the side very easily. So we're trying not to draw any air back down into the sample. Now we're going to start a timer for 10 minutes. It has to sit for 10 minutes. That allows the temperature to equilibrate. It also allows all those little microscopic bubbles in there to contract, achieve atmospheric pressure, and suck water into where those voids were. And the other nice thing about doing this in a clear vessel like this is that you sometimes will see air bubbles stuck to the glass. We're trying to get this device to have no air bubbles in it whatsoever. So any bubbles that are stuck to the glass while this is sitting for 10 minutes can be knocked off. This is just a little wooden dowel. When this picnometer was calibrated, this is how it was done. It was simply filled with water, made sure there were no air bubbles inside. The top was put on with no air trapped, and it was weighed, and it was done at various temperatures. From that we produce a chart showing the weight of that picnometer filled with water at every temperature from 72 to 82 degrees in half a degree increments. This test is very sensitive to temperature and time. So oh look, it's been 10 minutes. At the end of 10 minutes, we top it off. This is some water I also got out of the water bath here. Top it off. I actually overfilled it slightly, so there's a slight meniscus there. That way I could take this cover plate and and simply slide it on there and not trap any air under the plate. When this was calibrated, this picnometer was full of water but completely dry on the outside. So that is what we have to do when we weigh it now. And get the total weight. This would be W2 in the equation, 7,498.1. Now we need one more thing. The target temperature for this test is 77 degrees, and it must be within 5 degrees of that. So 72 to 82 degrees. I don't have a good temperature controlled bath here, so the chances of me hitting 77 are not real good. If you don't hit 77 exactly, then we have to compensate for the change in density of the water. So I need to get my final temperature here. These electronic thermometers read to the 1/10 of a degree, but our charts are in half a degree increments. Looks like 78. Two more pieces of information for the equations. The IM for this test is IM 350. This is the Appendix A to IM 350. It contains what are called the R correction multipliers. That goes on the top of the equation. So I had 78. The way this works is you find the 70, come across under the 8, and our R multiplier would be 0.9999. The other thing I need now is W1. W1 is actually the calibrated weight of the picnometer. So I have pic number 13. I have to find the sheet here, the calibration sheet for pic number 13. Find 78 in the far left column. Come all the way across. And my W1 then is 6259.8. That's the calibrated weight of the picnometer at 78 degrees, simply filled with water. All right. Okay, we demonstrated the test the way the DOT does this. They are often using the automatic equipment now that controls all the vacuum and timing for you automatically. Many contractors use this type of equipment called a metal bowl, and the procedure is still the same. This part of the device is placed on to do the vacuum. Once it's done and it's sat for 10 minutes, it has a calibrated lid that goes on that gives you a known volume. There's a little hole there. The water squirts out the hole so you know there's no air trapped inside. It is also now allowed to simply weigh the sample in the bowl underwater, not having to use the calibrated lid. So there are various ways to do this test other than what I demonstrated for you, but the principles are all the same, the timings are all the same. So whatever equipment you happen to run into, the procedures are still basically the same regardless.